Okay, perfect. So we're going to talk a little about how mixed reality is used in education, covering virtual augmented reality. This is actually a very fast-paced short presentation. If you already have some knowledge, it should still be engaging and interesting. If this is all new to you, it should be a great starting point as well. So um, before we start, kind of establishing a bit of a common ground and something that I like to talk about is the good old days, which, by the way, this entire PowerPoint was generated by Office AI design system. So colors, images, centering, and all of that is decided by Office. Hopefully it's good enough. AI is all around. We're not going to talk too much about AI in this presentation, more about the visual technologies, but just kind of a fun fact. So what about the good old days? So the reason why I like to start with this example, it's because some point long ago, like Diana was saying, we used to learn by reading a book, right? We would just, you go to your typical lecture, you take your books home, you read. If you're lucky, they have some hand-drawn pictures. Maybe later you have photographs, things like that, right? So we're all learning very standard, very typical method of acquiring knowledge. And then what happens? At some point, somebody decides to invent a box, right? A TV. And we all have heard the stories. Who's going to want to watch that box for a long period of time? Oh, it's really expensive. Only very few people are going to be able to afford it. It's very clunky. You have to go up and change it and calibrate it and do your best to actually get some signal, something out of it. And one of the first purposes of the TV was kind of telecommunications, right? You could see someone from a distance and they would convey information to you. So those were the initial goals of the TV. And that the reason why I bring it out, it's because it sounds very familiar to the current state of mixed reality, virtual, augmented, digital realities in general, right? Expensive devices. Who's going to want to wear this all day? It's clunky. Technology is not quite there. There's no content. You have two channels, maybe none in your city. So it's actually very, very similar to where we are at now. So now, what was the second step that most of us probably don't think about nowadays is some people said, well, now that we have the TV, this is going to revolutionize books. This is so much better. Now all students can learn from the TV, right? There's no need to read that book anymore. There's no need to have that pictures. Now you have moving pictures and audio, such a great medium. Let's all learn from the TV and let's all just learn from documentaries and stuff, right? And we all know that that's not exactly what happened. But if you notice, there's a big analogy with headsets and let's learn with this technology and let's all just learn in this new medium because it's the best. And that's not quite true. It depends a lot on the content, right? On what you do with your devices. So I have a really quick quote here. This is actually from the Academy blog. So this comes from the Academy, the one that gives the Oscar awards. And this is from a short film, documentary filmmaker, right? And so the way he does his filmmaking, well, it's one of his documentaries. It's thousands of hours that he reviewed about a certain topic, chose the best ones, put them in sequence together. Sometimes it's interviews, sometimes is reenactments, all sorts of things, right? But interestingly enough, they say, or he says, there's no business model for short films. We all do this because we're so passionate about the stories that we're telling. And again, you can see the analogy here where with these technologies, with virtual and augmented reality and mixed reality and the free applications that you download, nobody's really making a business out of it, right? It's a nice to have, and people who develop this are because they're very passionate about this. So what happens then? Why don't we have a documentary for every single topic there is for the entire book? Why don't we learn with the TV? It is because of this same reason, right? Because there's no business model. And so what's our fallback plan? Instead of having hundreds of documentaries for this really specific topics, we end with things like this, right? I'm not sure if she killed her husband. I haven't watched this documentary in particular. I've heard many things about it. But in the end of the day, why do we end up with something like this? Because this is what millions of people will watch, right? And it's entertainment, it's entertaining. And in fact, as a company and as researchers, we started in the entertainment area, right? We were doing theater and improv and some sort of filmmaking to try to create these more realistic applications. So this is what we end up with. But why, right? Why can't we do better? Or how are we going to do better with the technology that we have now? Well, Because we're talking right now in particular about visual technologies, we are thinking about ways to represent information in a better, more engaging, more interactive way, right? So when I used to work for a time in visualization with environmental scientists and with geologists and things like that. And you often see the marketing or the advertising of the companies that deal with the digital realities, something very flashy, something very futuristic, really cool looking, really smooth. But the truth is that, and those companies that actually use the technology, it's not the flashiest that wins the race, right? It's the most informative. It's the one where it actually takes the best out of the medium. So what does that look like? Well, I like to show this really small example about visualization of space, right? So in this visualization, you probably can barely see it, but this little dot right here, it's a pixel on my screen, or the equivalent. It's the moon. And this is the Earth, right? And so this is space to scale. So we've all seen models of the solar system and things like that. Here it is. If the moon was a pixel, this would be the size of the sun, right? And if you were traveling at the speed of light, this is how you would be moving. And if I leave it here, it's going to take over 8 minutes to reach the Earth, right? So this is a visualization that somebody did with pixels, and it's conveying some information, and we're learning something about space. And sure, it's kind of boring. It's very simplistic, but it tells you something that's really hard to get any other way, right? So that's what we want to get to. We've been 30 seconds talking about this, 10 million kilometers just now. We're kind of 1/16th of the way, in case you're wondering. I'm just going to scroll a couple of minutes. There's our first planets, and we're about to reach the Earth. Yeah, here we are, right? So, and if you see the bottom, I'm not sure if you can see it, but we are kind of just a tiny portion. We can continue doing this. I think it takes a couple of hours to reach the end. And people have done similar things with scale and other things. One other example that I like to talk about really briefly, because this kind of hits closer to home. You may remember that this past October, they did the border lights, or the border tuner, where you would use a light, you could control it from either side of the border, and where the lights collide, it would open a communication channel between the people controlling the lights, and then you could talk to them, right? So now, this is not the particular example that I'm going for. I'm going for the example where this same artist, he uses a lot of technology, and he wants to visualize the population of the world, right? 1 pixel per person, kind of similar idea, right? And so that means that we need about 8 billion pixels to visualize ourselves. And, you see the pixels changing color depending on nationality, gender, age, you name it. And all of a sudden, these numbers have a different meaning, right? You now see them, and they mean something, right? It's not 100,000 people die because of this. It's a huge chunk of a screen turns off because there was something triggering it, right? So it makes you handle information very differently. I use this as I teach at UTEP some programming classes and technology classes, and I ask my students to come up with how many screens you would need to do something like this. In case you're curious, about 754 4K screens connected to do the visualization of everyone in the world, right? So just some fun facts. But okay, we're doing this with pixels, and there's a lot of meaning, and it's really interesting, and it's really fun. So you would think, well, we have a lot of technology. How can we push this? How can we really take advantage of what's out there now? So enter virtual reality, right? So some of you may or may not know, or may be very or somewhat familiar with virtual reality. For the sake of all being on the same page, let's talk about Ready Player One. So this is a film based on a book. I both read the book and watched the film. And although it has a couple of things that are kind of out of character or kind of weird for the representation of the technology, for the most part, it's a pretty accurate, realistic representation of what it is, right? So in the movie, the main protagonist wears a headset, so kind of some funky looking glasses. It blocks your field of view, and instead it transports you to a 3D world, right? A 3D environment, kind of inside the software. If you're more classical and have seen The Matrix, kind of that same idea, but less realistic, more cartoony, but same principle, right? You don't die in the real world if you die in the virtual world, but other than that, you just wear the headset. Now, you can see that he has kind of a belt and he has some kind of gloves that lets him do some stuff. And he's actually seeing an entirely different virtual world. So this is replacing our real world with a 3D representation, useful for simulation, dangerous situations, simulating entire environments, doing all sorts of things. Now, how does the technology right now measure up to that? Well, first of all, the most basic form, and this is going to go fairly quickly as well, but you have 360 video. Funky looking cameras, bunch of cameras, they have a bunch of angles. You use special editing software. You capture the audio, you film in 360, and those are the types of videos that you sometimes see on Facebook or on YouTube that you can kind of drag your mouse around and look around. Now, the cameras, you can all buy one for a couple $100. Some of them plug into the phone, really easy to make, or you could go into a more complex setup, right? Maybe hard, has a lot of limitations with traditional cinematography because you cannot hide lights and things behind the camera. They're always visible because the camera is looking everywhere, right? Usually people do this for experiences, kind of like skydiving, jumping off from that waterfall, or doing X or Y thing that normally you wouldn't do. But you have to be careful when you design these things, right? Why? 360 video is not interactive. You're a passive observer. You can look around, but you can't do anything about that. Also, it has to have some replay value, right? What if I'm looking at the wrong place all the time? Or what if I'm always looking at the right place, but nothing else happens around me? Then there is no benefit to the technology. So we started somewhere, 360 videos and devices that can play them, but not very techy, not all the way up there. So what else do we have? Well, you know how he was wearing some gloves? You do have gloves. There's like 5 major companies that are doing versions of this. They look kind of creepy. They look like they will break your fingers if they malfunction. And allegedly, they let you touch, right? Touch, feel its sort of texture. Kind of, there's like now a new feel resolution thing used to measure this. It tracks your hands. It vibrates. Some of them heat up. Some of them pull back and all these sorts of things. So now you can use your hands not only to see them in these virtual worlds, but actually to grab things and interact with things with some limitations, of course, right? You cannot simulate weight, for example. You cannot carry a 25-pound bag because the gloves are not going to be able to simulate that, but you can still do lots of cool stuff. So, okay, we have the visuals. It's either a 3D game like, it's either the camera, we have touch. So how do we move around? Well, there's an app for that. No, there's a hardware for that. And there's also several companies competing in this space. There's many ways. This is kind of the more typical approach where you see this person right here, kind of a semi-sphere. They walk around, the feet slide back to the center, but as the feet move, they have trackers in them. And so you can actually walk around in virtual reality. I pre-ordered one of these in 2013, I believe. I still don't have it. So, but they've shown it in many trade shows and in some VR arcades. So they do exist. It's not a myth. So, okay, now you can grab things, you can walk, you can see, but what else to reach full immersiveness, right? Well, you can wear these types of vests. Ignore the other brand of gloves. Right now we're focused on the vest, because who wouldn't want to feel shot when you're shot in game, right? Like you really want to feel that punch. I don't know, it's kind of weird, but they vibrate, they heat up, some of them give like small shocks, things like that to simulate some feeling, right? Maybe some room for using this for training. So, okay, we can feel, we can touch, we can grab, we can see. It's getting better. Well, but if you want to ride a vehicle, sure, why would you take your bike in a perfectly outdoor ride when you can do it from your home? There are legit reasons why you would want to do this. People train in certain routes that they can't possibly be at the time, and the bikes or the vehicles will simulate the stress on it. And then you just visualize the route, right? So it might be a fallback plan. But who cares about the bike? Because you want to learn how to drive that car, or you want to learn how to compete in racing, or to drive that trailer. Well, there's also something for that, right? So you just wear the same headset, and now you have this full simulator car attached to the simulation, and you can actually drive a vehicle and control a vehicle all in this environment. But you do want to walk around in the real world, not just attached to this funky looking treadmill. So there's also an alternative for that, right? And here, this was released by Oculus a year or two ago, I believe. And in this case, you can see from the iPad, this is what the players are seeing, right? So this funky looking character right here is this person. And the boxes here, the real boxes, do match the virtual boxes. So there's several people walking around. This is wireless, a bit less powerful than those attached to a computer, processing-wise, graphics-wise. But now you see the person here also as well. You can walk around, see other people in virtual reality, see the boxes, move around, do all sorts of things, right? But you want more computing power, you want more people, not a problem. You can have these arenas where you can have dozens of people interacting, lots of power, computing power on your backpack, kind of Hollywood style. You know, you can simulate an entire building if you wanted to. Okay, so that's hardware-wise, right? So maybe the problem is not that we don't have the devices. Maybe the problem is that we don't have the software, the applications to do something like this. In the particular movie that I used as an example, it's Oasis, and it is a virtual world. But wait, there is Second Life, right? And it might be clunky and it might not be the best graphics that are out there, but it is a virtual world, right? They claim it's not a game, it's not a multiplayer online, it's not a chat room, it's not a business platform, it's not the web, but it uses all of the above and people can use it in all these ways. So how does this translate to education? Well, some people, these are some universities, University of Arkansas, Western Australia, top right is Edinburgh, and bottom right, I believe it's Kansas. They're teaching different things in these virtual classrooms where people do show up, right? And so all those little characters right there are actual people kind of in this virtual world attending virtual universities, right? So we have software, we have hardware, we have all that, but why don't we have this really high quality simulations? What's missing, right? And that's kind of where I'm going to wrap up the whole presentation. But before we wrap up, so far we've been talking about virtual reality, right? Completely virtual worlds, game-like 360 video. So now let's take a look about the other reality, right? Not the real reality, the augmented reality. So augmented reality works kind of similar to virtual reality, except you can actually see the real world. And this is sort of how it looks like. So now this is one of the ads that I was saying that they look very Silicon Valley-ish, very edited, lots of things. And so in this case, what we're trying to illustrate here, this is an image from Magic Leap, one of the manufacturer for these glasses from their website. You can see she's kind of clicking on this area and seeing a hologram for that room. In this case, she's clicking some things and they're seeing kind of like the pipes going through the walls. And in this case, they're looking at kind of the sun and solar efficiency, right, across time. So now, this is how many companies portray their products. But the question here, the real question is, what about all these things I cannot do from a regular computer or from a regular screen, right? Could I rotate a 3D model, maybe look inside a room? Sure. Could I drag this thing around and see how solar efficiency around this? Could I share a screen with multiple people? I can do all that, right? So, however, this is mostly how these things are marketed. For this purposes, it's just knowing that these glasses are kind of semi-transparent, and whatever you see it overlaid in the real world. So that's what augmented reality is. Without going too much in depth, Microsoft did a video promoting their HoloLens 2, which I am going to play for you right now. There's no need for the audio, there's just music. I think I have the subtitles on. Yeah. And so this is some of the capabilities, right? And there's a reason why I'm showing this. We'll get to it in a second. Right. So you get the idea um, about how augmented reality works or looks like. But then you saw hundreds of companies listed there. You saw great improvements, great benefits. There's just like no question about it. This technology helps you save time, reduce maintenance costs. It helps you communicate. It helps you do everything you could possibly dream of. And some things like time to access information reduced by 97%. And although many of these things are actually true, have you ever seen anyone using this technology, right? They showcased hundreds of companies. Many of them have offices, buildings, manufacturing plants in El Paso or in Juarez, which is the area where we're in case there's people from outside joining us. But in any place that you could think of, why isn't everyone wearing one of these headsets if they are so good, right? If they do all this? All right, well, maybe you've seen some people using it, but have you ever seen somebody using it regularly? You go to work and you use a computer for office work or things like that, and you use it every day. Why isn't every operator using this every day? Why isn't everybody using this every day? Okay, you might see some people doing this at trade shows or things like that. Have you seen them use it for something other than marketing, for something other than saying, this is high tech, this is fun, this is in, I'm an innovator, right? And that's just some food for thought. However, I do have somewhat of an answer, and then obviously I have solutions on how to start changing this, right? So, because otherwise, that's just a very pessimistic approach. So, why people aren't using this? Why isn't everybody using this? Well, expensive and fragile devices, right? Each of these devices costs a couple hundred, a couple grand. It's not feasible to give this to every single kid in your school. It's not feasible to give this to every single employee in your manufacturing plant. You're going to share the device, then it defeats a lot of its purposes, right? Because then now there's multiple people using the same thing. AI takes a hit because it usually learns from user habits, just like your phones do. And in the COVID era, you really don't want to be sharing something that you put on your face. So okay, that's one. But also, there's a lot of technology limitations, right? The things that they don't tell you in these ads or when they show these things that you discover kind of the rough way once you try to do something is that, oh, you need wireless and you need good wireless signal if you want to take advantage of some of the applications. Some of these headsets work with infrared signal, which means they don't work outdoors. They don't work with the sun. They don't work in really bright environments. Oh, didn't think about that. The computing power. Most of these devices are as powerful as a phone. So you're trying to do this architectural visualization. It looks really cool. And then you don't meet the expectations because the computing power, not quite there yet. The development cost doing an application in any of these devices, it's usually pretty expensive. It usually takes a lot of time. And then the language, right? You can't find applications in many languages. Sometimes, especially if you're using natural language processing, in other words, speech recognition, mostly just English, right? So there's a limitation for all those international companies. And of course, there's a learning curve in using this new technology like there is with any new technology. But we are nearing the end. So what is the reality? Where are we now? Who's using this absolutely every day? Well, this is where we are now, right? I literally Googled augmented reality examples, and this is one of the first images that I get. This is one of the Kardashians. I'm not even sure who she is of them, but face filters, right? Now, don't get me wrong. There's nothing wrong with using technology for entertainment or for fun or for dumb stuff like this. But if everybody's already kind of getting acquainted with these things, you think that we could do it a little better, right? Or do a little more. So what else do we do? That's actually being used in some popular applications. On interactive books, there's books where you point your devices and you see things pop up and you hear audio and you get more information. It's used for traveling, but it's kind of Google Earth virtual reality version type thing. You use Google Translate, which basically, I don't know if you've ever used it, but you point your phone at something that's written in another language and it'll actually overwrite the sign on top of itself with the language that you want to read it on. So those are some applications, but you can see that they're all complements of the main application. None of those are the core or the main purpose. So how does that look? Well, Sure, we have a book here and a kid is painting, and then the little painting kind of comes up to life, but it's just a novelty, right? So what's the value added? What's the real benefit from using this? Where do we go beyond this, right? Um, so fortunately, there is hope, and this is Microsoft's AI image for hope, a little plant. So I guess they're spot on. Um, all right, and we're nearing the end. So what is the main takeaway of all this? Well, what is the hope beyond all this? Well, without going too much in depth into the theory of learning, I know that there are some educators in the room and some of you may be very familiar with this or with other models of learning. But I guess we can all agree to some extent that some of us are auditory learners. We listen and we learn. Some of us are very visual. We need to see someone else doing it and we learn. And some of us are kinesthetic, right? We learn by doing, by touching, by feeling, by experimenting. So ideally, we all learn in all different ways, but we have some predominant traits, right? And what happens is that with virtual technologies, one might think, well, that's a visual aspect, and let's center on this aspect, right? And that's completely the wrong approach, right? Your goal should always be reach the center. Use all of the tools at your disposal, right? Don't do a documentary without the audio or the subtitles, right? Type of thing. Still, that lands you kind of here. So what are the main takeaways from this? Well, there is no solution that fits all. This is not something that you just pre-package and download and all of a sudden the magic happens. That is why we're custom software developers. A lot of this is custom made, and sometimes the expectations may be off. Definitely go beyond the visual appeal. All these things do perform better with the visuals, but just like the moon pixel visualization, you can go beyond how it visually looks and focus more on the inner workings, on the theory behind it. Take advantage of learn by doing, right? If you can track your hands, if you can track your environment, if you have all these technologies, don't just show people something, have them do something, take part in it. Use the same system to evaluate them, to see if they're doing it right, if they're doing it fast enough. Know who you're designing this for, right? It will be a very different approach designing this for elementary school kids, which we've worked with, than designing this for college students, than designing this for industrial operators. Different backgrounds, different audiences, different purposes, different balance between these three. So know it. I'm sorry about that. Identify the benefits, right? This is one of the most important things, and I mentioned it across the presentation. Before you move and do something with either of these technologies, what will it allow you to do that you could not do before, right? What can you do with this that you cannot do with a screen? If you cannot answer that question, then it's just a very expensive piece of software that you should probably have done on a screen to begin with. Now, sometimes you do find the benefit, your mind runs wild, but you need to know what the return on investment is, right? If this is going to be very expensive, how is it going to pay off across time? Does it pay off? Right? So if you don't want to end up using it just for marketing, well, what are the benefits that go beyond? Are you doing it faster? You know, like Microsoft said, they save $38 per unit and they deploy 2 million or something million units per year. Well, that's pretty easy to measure, right? Once you have it, keep track of it, improve on it, iterate, measure, analyze what your users are doing. And this, I don't mean as a developer, I mean as, you know, if you're a school, if you're a museum, if you're a maquila factory, keep track of it, right? And that way, you know, for next time, what are the things that work best for your particular industry. This is a very unexplored field. It's very new. Lots of people haven't used it yet. So it's great to get that type of feedback. Choose the right technology. First, we talk about virtual reality, which covers your field of view. Those are used for simulations. You saw people driving virtual cars and bikes and doing all these sorts of things. You don't see people doing that with augmented reality, right? Augmented reality, we're just kind of the real world overlaid with holograms types things. So choose the right technology for each, or ask someone who knows what they're talking about to help you decide. Empower rather than replace. So a lot of times people have this feeling that, oh, this technology is going to replace me. It is going to replace some of the low-end jobs, or it's going to make some of those jobs faster, right? Meaning that you require less people, but it opens up a lot of other opportunities, right? So for example, sure, some people could argue, hey, if you have this headset that tells you everything that a technician knows at the tip of your fingertips, then you're not going to need technicians anymore. That's not true. It means that your regular operators can now perform as technicians, and technicians can also upskill their their trade and do something more advanced. So it's just allowing people to do something better, to empower them, not to completely replace them, right? As always, work smart rather than hard, right? If you find a small piece of software or a small thing that saves you 80% of time with 20% of the effort, then take that rather than always going towards that 100% that it's usually always unattainable. And iterate, right? Do it multiple times. Keep improving on your previous solutions, especially if the software that you're acquiring leaves you some leeway to kind of do some alterations, modifications, or future versions. So with that, I'm going to wrap it up here. But I do want to mention real quickly, so these are some of our members of the team and engineers that have been with us since the very beginning, and a couple of trade shows, Alex, Marco, Laura, Aaron, and Julie, who are not here, obviously Diana, Juan, who's also not here for some reason, and the work of a lot of our interns, right? We've had a lot of people working on these things, and the presentation that I give, it's usually a summary of the work of the entire team. So I get the privilege to share it with you, but it's the hard work of these and a lot more people that are behind the scenes. To the right on this particular slide, you see some of the projects that we've done, kind of just listing them really quick, and then you can ask if there's one that you find particularly interesting. But my doctoral work was in virtual rapport and empathy, kind of building empathy and relationships with virtual human beings. Laura's master's thesis was about doing immersive history. You know, you walk around Boston in 7070 in virtual reality, an entire simulation, stimulate critical thinking. Don't read the history. Go and ask a slave why they're upset. Go and ask a shop owner why they have problems with taxes in colonial America. Go talk to John Adams and see why he's having trouble with the representation, right? Very different approach. Virtual World took about a year to make. It plays for about 30 minutes or so. So that's kind of, again, one of the trade-offs, right? Harry Potter and the IBM Watson Natural Language Processing AI system. It's probably the one book that you didn't read about Harry Potter, but we worked with IBM Watson to create kind of a virtual Harry Potter that responded to you talking to it. And he basically had all the knowledge in the books. Those we did pre-Boost Human as researchers, and then telepresence, augmented reality telecommunications. I'll show you a video in just a second. Virtual training. There's many examples for quality assurance, simulations, things like that. Smart guides, it's basically seeing holographic information relate to you as you're working. Could be text, it could be audio, any type of instructions when you forget what you're doing or when you forget something that you previously learned. Virtual patients, we do holographic patients that you can see through HoloLens. So basically your task is to diagnose them, talk to them, actually use your speech, and they can have different ailments, different behaviors. Holo Lauda, this is kind of a City of El Paso chatbot that appears on some of the city's websites. We did an actual holographic real-life representation using some LED fans that actually display a hologram in front of you. And you could also go to her and ask her through a microphone, and you would see a hologram of a person, very Star Wars-like-ish, talking to you. Layouts for items or structures. This just means that you can put things around for visualization. It could be an entire building, an entire floor, or it could be items inside the building or the floor. Virtual tours kind of go hand in hand with that, but you could also have virtual tour guides where you're walking around and you see a hologram of something or someone talking to you, explaining you, pointing you in the right direction. Virtual curriculum, we work with some schools, particularly technical schools, when you need to have that vehicle, that motor, that HVAC, those really heavy pieces of equipment that students can't really take home to work on. We do all that. So I can talk a lot more about any of these, but I'll leave it up to the questions if there's interest. The last thing I'm going to show, promise, it's this video. also going to talk a little over it. These are some of the solutions that I mentioned, right? So this is an augmented reality application from a phone. You can see different body parts. You can get quizzed about different body parts. The quizzes get harder. You learn from it. These are the virtual patients. To the left is one of our engineers, Alex. To the right, it's kind of his point of view or the holograms that he's looking at. The holograms are talking with each other, but you also get to talk to them, right? No controllers, no hands, no nothing. He's diagnosing Nick O'Time. That's the name of the patient. This is just a tech demo, kind of using voice commands, a console, and dragging things around with his hands. This is also Alex ordering a machine that obviously it's a fake machine. We cannot show the actual proprietary information of our customers. This is a training simulation. Some of you have seen this. Some of you have tried this. This is in virtual reality. Handle virtual equipment for inspection. And then all these connects to data and analytics and all this sort of fun stuff. And that is basically it. So if you want to see more about some of the things that I was talking about or about the team, you can go visit our website. You can reach me out at ivan@boosthuman.com. And you can reach Diana, who's hosting the webinar at diana@boosthuman.com.